Good morning, everyone. Thanks for coming along today and squeezing in. It's a big crowd in here today, so thanks for your patience as well. I know we're starting a bit late, but the keynote went over a little. It was hopefully interesting and exciting for you all. My name's Ray Maya. I'm a developer advocate for Android at Google, and today I'm going to talk to you a little bit about how to get started developing for Android. Before I do get started, I want to point your attention to this bit.ly link. We're going to be doing live waves for each of the sessions at Google I/O this year. So if you want to become a part of that, have some conversations with people at the session or reading your notes from afar, follow this link to I/O Android 1, the bit.ly link. If you want to tweet about it, the tweet tag for this session is Android 1 as well. So one of the things that I like to ask whenever I do these sessions is how many of the people in the room have Android phones? Wow, that's phenomenal. Wow, how many have like the coolest new phones, like a Droid or a Nexus 1 or something like that? That's incredible. That's really okay, how many of you, in fairness, how many of you had these phones before we sent them to you for coming along? Well, that's pretty respectable, I have to say. I'm impressed. So that's great, and it's even better to see you guys here with the phones trying to find out how to actually be involved in creating apps for it. So, what is Android? Android is an open source, open platform for mobile development. All of the You know what? I feel like I've given this slide before. And if I have a look in the audience, I feel like I've probably given this slide to a few of you beforehand. Is there anyone here who doesn't know a little bit about Android at least? Let's ask a little bit differently. How many of you have downloaded the SDK, maybe installed Eclipse and the plugin? Wow, okay. And how many have done your first app, you know, something a little more than Hello World? Yeah, okay, so that's most of you. So we can probably skip this really basic stuff. And we had a boot camp yesterday. All of this information is online at developer.android.com. So if you really do want to understand the absolute fundamentals, check this out. It's got everything you need. It'll tell you all about the APIs that are included, give you tutorials, sample apps, those sorts of things. What we're going to do today, I think, is something a little bit different. In the past, it's been all about, as a developer advocate, it's been all about telling people about Android, getting them excited. I think, judging by the number of people with Android phones and who've already gotten started, we're a little beyond that. Now it's all about quality, showing you guys how to build better applications. So today, instead, I'm going to present to you some best practices for beginners on Android to help make sure that you guys, when you get started, are creating great apps, not just any app. So, as a developer, you have a choice. You can be a good developer, or you can be a lazy developer. And like any choice, that choice has consequences. As a developer, you're absolutely at the mercy of your users. If you create a bad user experience, they're going to uninstall your app, they're going to give you 1 star, they're going to write a snarky comment, and before you know it, your app is going to disappear. It's going to drop down the list of top apps. When people do find it through a search, it's going to have 1 star. They're not going to bother with it. If they do, they have a bad experience. They do the same thing. Before you know it, your app is gone. On the other hand, if you're a good developer, if you use some of these best practices, then you're going to create an app which people love. They're going to use it. They're going to keep using it. They're going to give it high rankings, positive comments. It's going to show up on the top lists. It's going to be the app with 4.5 stars when they do a search. People are going to talk about it. People are going to use it. It's got the potential for being featured. This is what you want. So on the assumption what you guys want to do is become good developers, what I want to talk to today is I want to give you 5 examples of things you should not do, 5 examples of things that you should do, and in the last 10 or 15 minutes, I want to give you a couple of practical examples of areas within Android development where you can really, a few simple best practices can really improve the quality of your applications, make them more useful and more performant within the system. So we're going to start off with the 5 deadly sins of Android development. First one is sloth. It is key that your applications are fast and responsive at all times. The 2 golden rules for creating performant applications within Android are to not do any work that you don't need to do and not to allocate any memory if you can possibly avoid it. Now, the Android developer website, developer.android.com, has a whole list of performance pointers, some of which are summarized here. I'm not going to go through each of these in detail. Again, it's on the website. You can do that there. But what you'll find that all of these have in common is that they in some way or another refer back to those previous two golden rules. They don't do any work if they don't have to do it, and they avoid allocating memory, such as creating objects, if they possibly can. And the reason why these are so important is because small changes in efficiency within your application in such a resource-constrained environment as mobile phones can have a significant impact in the performance of your application. And so even things which you probably would never have considered, and many of these, certainly from a desktop developing background that I'm from, I wouldn't have given a second thought to, because they seem like such minor improvements in terms of efficiency. But in a resource-constrained environment, this can have a significant impact, and it's something that you really do need to pay attention to. Just as important as performance, if not more so, is responsiveness. So mobile users, they do not have any patience. I mean, you're all mobile users and you know what it's like. Your mobile phone is something that you're using on the go. It's not something that you're sitting down comfortably in front of a workstation where you're willing to, wait for something to load. Basically, everything needs to happen immediately. And the same thing is especially true for your applications. And so you need to make sure that users can have that instant gratification. And what that means is you don't want to have modal loading dialogues where people are seeing a spinning beach ball or an hourglass or anything along those lines. They need to be able to interact with your application instantly. So if you're creating something like a news app, for example, rather than having a loading dialogue which comes up and prevents the user from doing anything, what you want to do is allow them to continue to interact while updating them on progress and then showing them whatever information you can as quickly as you can. So that means downloading the news headlines and filling them in as you decode them from the input stream. Going back afterwards and adding the images as they get downloaded. So rather than waiting until everything is finished and ready to go, you're gradually increasing the amount of information available. And you can extend this to things like prefetching. So if it's a news app, something like that, you'll fill in the information for the first screen, and then while they're reading that or while the user's doing anything else, you're prefetching the data for each of the other sections that they may navigate to. And the intent here is that as soon as your user is using the application, they're not having to wait any longer for things. It's available as soon as it possibly can be. And this is particularly important for something like a mobile phone, where your data bandwidth is going to be limited. It's going to take some time for a lot of these things to load, so you need to do everything you can to remove that lagginess. How many of you have seen one of these? Yeah, come on. I think a few more than that. If your user sees one of these, you've already failed. It's absolutely the worst thing that you can possibly have your user see. The documentation will rightly tell you that you will see one of those application not responding dialogues if the user tries to perform an action on your phone and the device isn't responsive within 5 seconds. So you have 5 seconds to respond before you get the ANR of death. Now that's absolutely true. It's also a little bit misleading. In reality, you have between 1 and 200 milliseconds before your users are going to start thinking that your application is laggy. So it's important that you move anything which can in any way take longer than just a fraction of a second and interrupt the UI flow, that you move it into a background thread. So there's a number of ways you can do that. The most simple and straightforward is, of course, just to use Java threading to move all of those time-consuming operations into a thread. Of course, that brings with it a whole lot of issues with doing things like synchronizing to the UI thread so that you can update progress and change the UI depending on the progress of your background activity. So what we've created in Android is a class called async task. And what this does is it wraps up that model for you, so that rather than having to do all of the thread handling yourself and the UI synchronization, you can implement this class and have it do it for you. So it's a generic class, so all of the parameters here can be defined to whichever types that you want to use. In this example, I've kept it simple and left it as void. So as you can see, the do in background event handler is where you actually do this time-consuming operation. While that's happening, you can regularly publish progress. So if you're, for example, downloading multiple pictures and you want to update the UI with each picture as it comes through, or simply update a progress dialog as you're performing this action, you can call publish progress, optionally pass in a parameter, and that's going to fire this on progress update handler, receiving that parameter if you pass one through. And this is already synchronized to the UI thread. So you can update your UI, you can trigger a notification, call up a toast, anything like that, and you don't have to do the thread synchronization work. Similarly, once you've completed your background processing task, you can optionally return a value. that's going to get passed into on-post-execute. And again, this is synchronized to the UI thread, so you can do anything you want here, modify your UI with the data that you've been processing, notify users that it's complete, anything like that, and the synchronization is already done for you. The next sin is that of gluttony. So the only thing worse than having an app that is slow and unresponsive is an app which makes the system slow and unresponsive and drains all of your battery as well, just for good measure. The key is to always use your system resources responsibly. So to avoid being a bad citizen, what you want to do is make sure that you're being very respectful of power. Don't use power unless you absolutely have to. Don't do updates more often than you need to either. And that can be updates from location listeners, from accelerometers, widget updates, anything which is going to cause the phone to wake up or to listen to a sensor or to do any kind of action. You want to do this as infrequently as possible. Now, obviously, there's trade-offs there against usability, but it's still important to try and find out what's the minimum amount we can do, which is still going to make it a useful, usable application. Things you should do. Find ways to share data. Processing data, pulling it down through the network, all of these things are going to consume resources. Battery, internet bandwidth. If you can find ways that your application can share that data between other applications, whether it's yourselves or third parties, or if you can leverage data from another application or from something natively, this is an opportunity to reduce that resource use. Similarly, wherever possible, you should be event-driven. So there are some circumstances where you'll need to do polling. That's the way it is at the moment, certainly. But wherever possible, you should be listening for system events or for broadcast intents from your application or others. And we'll talk a little bit more about how you go about doing that later in this session. Possibly one of the most important things is to let the system manage resources. So a lot of the Android framework team, their whole goal is to find ways of being able to make the framework manage these resources. So it's important to try and find ways that you can work with the system to take advantage of those optimizations, and importantly, not try and fight against what the system is doing. How many of you are familiar with a wake lock? Right, I may very well regret showing you this, but this is a wake lock. What it is it's a way to force the device to stay on. So you can keep just the CPU running, or you can keep the screen on as well. And that's in fact what this particular example shows. We're using the Power Manager to create a new wake lock, which is going to keep the screen on, though optionally dimmed. And then what we're doing is calling acquire, and at that point, the screen and the CPU is going to be kept on until this wake lock is released. So in this example, we've specified a 10-second timeout, so no matter what happens, it's going to be released after 10 seconds, unless we release it first by calling release. Now, wake locks are really cool, they're really useful, and very important, particularly if you've got things happening in the background, if you've got things happening on a regular basis or responding to system events, which may occur while your device is on standby. You need to use wake locks to make sure that it doesn't turn off while you're in the middle of completing a task. The thing is they're very powerful, but it also requires a lot of responsibility on your behalf. So if you are using wake locks, you need to make sure that you really need to use one. It's tempting to just use it wherever you can. Oh, this is something that should be completed. Unless it needs to be completed within a certain period of time, don't use a wake lock. If you do need to use one, use the minimum level of wake lock possible and use it for the shortest amount of time that you possibly can. So that's in the example that we gave that you just saw previously, we had a 10-second timeout to make sure that no matter what happens, it will be ended in that time frame. So this is an important thing to do to make sure you're not holding wake locks and draining the battery unnecessarily. One of the other things I want to point out is that in most cases, you shouldn't actually need to keep the screen on, certainly the CPU, but the screen you shouldn't have to. Now, if you are creating an application which does need the screen to be on, a video player or something like that, where the user isn't interacting, but you want the screen on, there is an alternative, and that's to let the window manager handle it for you. So rather than using a wake lock to keep your screen on, what you can do is get a handle of the window and pass this keep screen on flag to it, and that will let the window manager handle the wake lock for you. So then you don't have to worry about finding out all the different ways that your activity can be hidden, when it should or shouldn't be keeping the screen on, and managing these wake locks. You're essentially letting the runtime do that for you. It's a much safer, much more secure way of doing things. Please, don't be the developer which makes the user pull the battery. Don't be hostile, don't fight your users. You're there to create an experience which is good for them, and they should be one of the They should always be your top priority. You absolutely live and die by your user's experience, and so you absolutely need to make it a good one. And you need to respect those user expectations for the way that your application behaves. When I asked my team for some best practices around Android development, what sort of things should I share with you guys, this is one of the quotes that I got back. Doing what the user expects with respect to navigation flow is absurdly important for overall user satisfaction. I really like this because it summed up a few thoughts that I'd had and which were particularly important to me when explaining to people how they should be creating their user experiences. Users have been using their phones for a lot longer than they've been using your apps. They're going to use other apps which have been on the phone for a lot longer than yours as well. And so they have expectations for the way that your applications are supposed to behave. Interfering with those expectations just makes it harder for them to use your app. So while you do need to make sure that it's always easy and intuitive to learn and to use your application, you also need to think about it in the greater context of an Android device. So one of the particular ones that I want to call out to you today is the back button. So the back button on Android is a little bit unique. It's not something which you see on a lot of other mobile platforms, but it's also absolutely integral to the way people use their phones. And the key to the back button is in the name. It means back. It's going back to something that you've already seen. You should never be seeing a new screen when you hit back. It works the same way, or at least it should work the same way as the back button on your browser. So every time you hit back on your browser, you're going to a previous web page or website that you've already been to. You're not navigating to the home page of a new site. So if you navigate from one site to another and then within pages, hitting back will always take you back through these other places. And that's exactly the way that it should act within your application. It's not an up button, it's a back button. So of course, respecting the user expectations in terms of navigation is definitely one important part, but it's not the only expectation that you need to respect. Phones are really extremely personal devices. They're something which people use their phones in ways that are unique to them, and they will have workflows built around those expectations. And so again, it's important that you not interfere with the way that they expect to be able to use their phones. So what does that mean? It means there's a whole bunch of things, again, which are around Android, and because it's so open, you can pretty much take control of the user experience in any way you want to. And one of the ways in which people do that is by hiding the status bar. Now the thing about that is that it's great. You get an extra 20 or so pixels at the top of your display. And if you're creating a game, this is an absolutely legitimate thing to do. You want to create a fully immersive, full-screen experience, and users have an expectation that that's the way it's going to work. But I've seen apps do this just because they'd like to have a bit of extra space. And what they may not appreciate is that by doing something like that, the user then loses their status bar, which means they don't get the clock, they don't get notifications, they don't get a variety of things which they're expecting to be there. It makes it harder for them to understand your app and to use it. They're much more likely to try and find someone else who's done the same sort of thing as you, but are letting them use their phone in a way that they're familiar with. So it's really important that you not hijack the way in which people use it, so that they can continue to use their phone in the ways that they've personalized for themselves, while also making use of your application. So far, the previous 3 points have all been sort of implicit expectations or contracts with the user. It's the expectation that your app will work well within the context of Android. This fourth point is much more explicit. It's the idea of obeying what users have explicitly told you that they want your application to do. This is particularly important around things like location privacy and anything which has a cost implication. Particularly for something like location privacy, that can even have legal implications in some countries, where if you don't give the users the option to opt out, then you can run into real problems. So one of the system settings that you can actually do on your Android phones is to turn off background data transfer. So I don't know how many of you knew that. What I am curious to know is how many of you do know that that's something which each application has to respect individually. Right, so this is how you do that. So this is how you find out whether or not a user has enabled background data transfer. Using the connectivity manager, it's a simple call to get background data setting. There's also an intent that gets fired if the user changes this. So what that means is that if this is turned off, then your application is not allowed to transfer data in the background. Now it still can. It's up to you to turn it off. but it's something the user isn't expecting. And so if it is transferring data in the background and the user is getting hit for a $1,000 roaming phone bill, it's you that they're going to be angry at. So it's really important that you respect that. The next sin is that of arrogance. Don't fight the system, it will most likely win. What do I mean by don't fight the system? It's doing things like not using unsupported, or I should say undocumented APIs. And it's important, I'll say it twice. The reason for this is pretty straightforward. It's for your own good. It's not for any other reason except for the fact that if they're not documented, the reason for that, more often than not, is because we think it's going to change. So you can use these undocumented APIs. It's all open source. You can see everything that's there. There's nothing to prevent you. But then when the next release of Android comes out, your app is going to break. And you're going to have to spend a lot of time trying to figure out how to then make it work with this new version, possibly even before you have that update on your phone, or even the SDK to do anything about it. So it's really important that you think long and hard before you make use of anything that's not officially supported. Just as important, and this kind of goes back to the topics we were just talking about previously, and that's make sure that your application is consistent with the system. Don't try and fight against the way that the system normally works, because that's going to be in line with the user expectations. It's going to make it easier for the system to optimize resources. So try and find ways to work with the system rather than trying to find ways to work against it. Related to that is respecting the application lifecycle model. So you've all got the SDK, you've all gotten started, which means hopefully you're aware of the application lifecycle within Android. So what that means is that there's a bunch of ways that your application can be switched out, or in fact can be terminated by the runtime to reclaim resources for other running activities. So it's really important that you use things like on pause, on stop, on start, on restart to make sure that that transition is invisible to your users. As far as they're concerned, your application should always just be sitting there a moment away from being the active foreground activity. So you should be saving state, saving data, caching things so that they're not having to restart the app each time they switch to it. They're simply switching back. So the final slide, the final sin that I want to cover is that of discrimination. Designed for everyone. One of the big strengths of Android is that there are a huge number of handsets, and if you've been out the front here, you'll be able to see this massive bookcase of Android phones, and there's a few dozen there at least, I think, and it's all different screen sizes, hardware types, supported things, and many of them running different platforms. And so this is the latest breakdown of the different platforms that are available. So you can see right away that if you're targeting a single platform, you're already cutting out 2/3 of your users. If you're targeting a single device, then that's going to be even more extreme. So you need to find ways to include everyone. At the same time, if you design for the lowest common denominator, you're going to be restricting 2/3 of your users from having some of these advanced features. And so there are ways in which you can support everyone while still including the advanced API features for the people which have those platforms running on their phone. The key to that is to not make any assumptions. It's to design for multiple displays. It's to design expecting internationalization right from the beginning. It's all about externalizing everything you can so that you can support as many different locations, languages, and features as possible. So how do you go about doing that? The key is externalization. There's a resources framework within Android that's very powerful, which lets you externalize pretty much anything. So you should never have a hard-coded anything in your code. If it's a string value, a dimension value, anything like that, colors, they should all be externalized into the resources hierarchy so that you can have different variations for different locations or different hardware. And so you can create an optimized experience for everyone who's using your application. Even within resources, if you're creating an array of strings, each of the values within that array resource should be a link to another resource, string resources. So the way that actually looks is like this. So within your project folder, you have a resources subdirectory, or res subdirectory, which contains the resources. And as you can see on the right-hand side here, we've done that for string values. So we have different values localized for a number of different languages. On the left-hand side, we've done something similar for assets. So you've got 3 different icons for the different resolution categories supported, and optimized layouts for each of the screen sizes as well. Now at runtime, Android is going to go through, look at the device that it's running on, and pick the right values from all of these things. And so you as a developer don't have to do anything other than have these externalized resources, and you're going to get the best possible result for any variation of the hardware that your application is running on. Now I could go on about this for the rest of my hour. I won't, because Justin is going to do that this afternoon. So if you are interested in exactly how you can do these things, things like using reflection, things like using this resources hierarchy to be able to create this optimized experience for as many users as possible, I strongly urge you to check that out this afternoon. So that neatly covers everything that you need to avoid. So I want to lift the mood a little and cover a few things that you really should be looking at doing. So it's the 5 glorious virtues of Android development. The first one is that of beauty. How many people in the room are designers? Yeah, we got a couple. Nice, thanks for coming. How many of you guys who aren't designers still create the assets and do the workflows and the user experience and the layouts and everything for your applications? Yeah, that's actually fewer than I thought. I think some of you are a little shy, but even still, if you're serious about this, if you really want to create an application that's great rather than just good, you need to be serious about the way your application looks. You need to be looking to hire one of the first lot of guys which put their hands up. So hopefully you'll be popular later in the day. Beauty is important. If you are designing and implementing the designs which people do for you, there is a session again today at 4:15 after Justin's on Android UI design patterns. So that's going to talk a little bit about the sorts of workflows and user experiences that are standard within Android and how you can go about implementing those in an efficient way. So if you're involved in the UI designer implementation of your applications, and I think it's fair to say that most of you will be, then this is definitely a session that you want to check out. So rather than go into too much detail, given that there is this session later in the day, I just want to cover a couple of specific points while I do have your attention. The first one is to create assets for large devices. So far the trend has been increasing resolution, increasing sizes, and there's no reason to believe that that's going to go anywhere other than continue to move in that direction. So what you need to do is make sure that you create those assets as big as possible. So that means scalable vector art or large raster images which can then be scaled down and optimized for the lower resolutions. The key thing really is being resolution independent entirely. We're no longer in this place where you can assume that mobile phone screen sizes are going to be a particular size or a particular resolution. There's already a whole collection of different screen sizes and slight variations in resolution. Your best bet is to be independent of that wherever you can be. So use device-independent pixels, use relative layouts, all of these things which we've had to be doing in web and desktop development for a long time. It's the same situation for mobiles. You can't make assumptions about the screen that your apps will be running on. Two things which I do want to point out, because you guys are new to Android, are these two tools, Layout Opt and Hierarchy Viewer. So these are within the SDK Tools folder of the SDK download, and they will help you to analyze and then optimize your layouts. Once you've worked out what it is you want to display, this will help to make sure that you implement that in a way that's efficient and performant. So definitely check those out. So for the next few virtues, what I want to do is, rather than just talking about it, I want to show you a couple of examples of applications which make use of some of these virtues. So the first example I want to give is that of generosity. It's the idea of sharing and consuming functionality within your own application so that you can bring multiple applications together and share some of that functionality. So the example here is Where and OpenTable. Where is an application which lets you find things like restaurants. OpenTable is an application which lets you book tables at restaurants. So it should be fairly simple to see how these two things should be able to work together, and that's what I want to demonstrate now. Brilliant. Okay, so if I open up Where, look for places, restaurants, American, in the local area. Excellent. We'll have a look at source here. It's 4.5 stars. That looks quality. So, as you'd expect from any of these sorts of sites, it's got a picture, it's got ratings, phone number, which we can use to dial the restaurant and make a booking. And down the bottom here, we have a Reserve Now button. If I press that, it opens OpenTable, which then has a look at the restaurant which we've passed in, which is source, lets us find a table, gives us the options for what times are available. We can click that and we can then make that booking. Oh, I won't make the booking because there's an after party at Google I/O tonight, so I'm going to go to that instead. And just to show you that it is two separate applications, we can open OpenTable separately from that icon there. So I think that's really cool. I think that's something which a lot of applications can make use of. So the question is, how do they go about doing something like that? And it's through using intents. And intents are one of the most fundamental things about Android, the power of it and the way things actually work, the way you glue together different activities in different, either within your own application or between multiple applications. So using intents, you can share this functionality and leverage functionality from other people the way Ware and OpenTable have done so today. So rather than just talk about it, I'm going to show you exactly how they go about doing that. So the way you do it is you create a new intent. An intent consists of an action that you want to perform and some data that you want to perform that action on. So within your own application, you may choose to start an activity by creating an intent that specifies the context and a particular activity class that you want to load. So that's what I call it, like an explicit intent. You're saying, open this activity, I know which one it is. What this demonstrates is a way to create an implicit intent, where you're saying, look, I don't know which application can do this, but I want someone to be able to fulfill this booking action against this hotel. And I'm just going to start an activity in the hope that someone is able to do that. And there are ways to peek to make sure that an activity does exist, to point people to the market if there's a particular application that you would like to have, suggest to them to use to fulfill it. On the other side, if you have this application which can fulfill this request, the way that you announce that to the system is to add an intent filter to your activity node in the manifest. And here what you're saying is, I'm capable of performing this booking action on this hotel name data. And so you can see when the previous application calls this intent resolution is going to go through, find this filter, and it's going to cause this activity to start. Within the activity, you can then call getIntent to find the intent that was used to start this activity. So it's going to be this booking intent which we had in the previous slides. Call getAction and getData to get the action and data to confirm it's the action that you want to perform. Pull out the data. In this case, it'll be the hotel name, and then you can use this to populate your form. In the case of OpenTable, that's obviously the restaurant name and the ability to make those bookings. It can be something similar or different for hotels or for any other action that you can think of and any other kind of data. Update the UI, allow the user to complete the action, and then when they hit OK or cancel, you can set a result. In this case, we've set OK. The null parameter there is actually an intent. So you can, for example, using the full intent data, add extras to this calling intent, which has, say, an affiliate code. Then you can return an intent which has something, for example, a booking reference number. So you can pass this data backwards and forwards beyond just starting a new activity and including it within your workflow. You can actually have data passing between these applications anonymously. And this is really powerful. And to me, this is something that I hope that you guys, as beginners to Android, really have a think about. If you're creating an app, if you have some functionality, how can other people use it? How can I expose parts of my workflow to give another way in for users to be able to get access to that, even if they're not launching my app from the start menu or from the launcher or from the home screen? And at the same time, if you've got an application, how can I leverage what other people have done? How can I use that within my own application to provide users with more functionality? So I think it's really exciting. I hope it's something that you guys take away and have a real think about. The next virtue is that of ubiquity. And for this, I'm going to use one of my own applications just to demonstrate the sorts of things that you can do to make your app more than just an icon on the launcher. So again, you can see the application shortcut. It's Earthquake. What it does is pulls the US Geological Society's earthquake RSS feed and gives you a list of all of the most recent earthquakes and what their magnitude was. But the reason I want to show it to you today is just to show the different ways in which you can have your application be used by the user or visible to the user. So the first things you'll notice here are obviously we've got two different home screen widgets. We've also got live folders, so this all quakes small icon on the top right. If we click that, it's using a content provider to give us a list of all of the last earthquakes which the application has found. So again, users can have that on their home screen. We've also got a shortcut here. And if we have a look at the status bar, we've also got a notification. So at the moment, I've got it set to poll regularly. Whenever a new earthquake is detected, it's going to fire a notification the same way as you would get for email, which, as you can see, shows you the last location, time, and magnitude. So, I mean, these are all fairly straightforward things, and they're really easy to do. And what it does is it makes your application more noticeable. It provides more access points for users to get to your application functionality. So by doing things like creating widgets, populating your search results from your own application into the quick search box, using live folders, live wallpapers, notifications, all of these things, it provides you a way to really expand the engagement of your application. And what we've found is the more engaged people are, the more different ways they find to interact with your application, the stickier it becomes. The less likely they are to uninstall it, the more likely they are to find more ways and more opportunities to use that application. So the excuse me. The next virtue I want to cover is that of utility. So you can create and launch almost any application that you want to in the Android market. It doesn't necessarily mean that you should. There are 30,000 or over 30,000 apps in the market already, which means that if you create something, you need to find a way to stand out. And that means being useful or being interesting. Ideally, it's being both. So one of the applications that I want to demonstrate for this purpose is actually, it's not particularly exciting, though, you know, your mileage may vary, I suppose. What it does, it's an app called From Ocado, which is an online grocery store in the UK. And I use this to do my shopping so that I can do it from the comfort of my home. And what this app does is it's fairly straightforward. It lets you shop. And the key to it is that it's a particularly useful app. It's something that I need to do. It's something that I don't particularly enjoy doing. And this app tries to make it as simple for me as possible. So one of the features it does is it does all of this offline. So the first thing it does is downloads the entire catalog, which it keeps synced. And you can, in fact, see the catalog sync starting in the background, which will then let me browse and do my shopping while I'm on the underground, which in the UK doesn't have any Wi-Fi or 3G access. So I can still do that shopping even without having internet connectivity, which is helpful for me. They've also made use of a couple of really nice features within Android to make this even more useful. And the first is voice search. So if I hit the microphone icon, bananas. Oops. Come on, internet. You can see that it will search through its database, and with any luck, it will display loading. No, it will show you some bananas, which is helpful. So this is a great way that I can do my grocery shopping while reading through recipes or wandering through my kitchen, and I can just hit this button and call out the things that I want to shop and then add them to my basket, which I think is really neat. And the final thing I want to demonstrate is barcode scanning. So again, they're using this idea of being able to integrate other applications so that, again, I can just hit, sorry, here we go. So it's a box of tomato puree. So again, I can hit the barcode button, and what that's going to do is open up the barcode scanner, which you can see, which is a third-party application, barcode scanner, which hopefully some of you guys have installed for today to do the scavenger hunt, and that finds it for me. So again, I mean, these things, they're not incredible, they're not that exciting, but they are really useful. And what they do is demonstrate a need, a utility, which people are going to find useful. And so that's the key. If you are creating an application, make sure that it solves a problem. Make sure that there's a reason why people are going to download it. Now, it can be something practical, like shopping, or it can be something far more pragmatic, like I get bored waiting for the train for 10 minutes every morning, and so I want a game which I can play casually and keep me entertained for that period. That's useful. You need to think about ways in which you can create something which people are going to want to use. The last glorious virtues is an important one. It's so important I kind of needed to invent a word to make it fit into the slides. It's epicness. It's being legendary. It's thinking outside of the box of creating an app which is just a version of something which you can already see on a website. The reason why I haven't got an image there is because it's stuff which you haven't considered yet, something that no one has considered. It's finding new paradigms and new ways to use the hardware that haven't been used beforehand. And so there's some really great examples of this, of companies which have thought beyond these sort of basic ideas. People like Shazam, which will listen to the ambient music and tell you what it is that you're listening to and give you the opportunity to buy that music. It's Google Goggles is another good example, which lets you use the camera to take photos of things in your surroundings and tell you what it is you're looking at. Or augmented reality, immersive augmented reality like Layer or Wikitude, which uses the compass, the GPS, accelerometers, the video camera to let you stand where you are and overlay contextual information into the world around you. And these are really great, really innovative ways to use this mobile platform, and it's these sorts of things that you should be considering and thinking about how you can create an app which is going to stand out in a market with tens of thousands of applications. So that covers the sort of the 10 high-level do's and don'ts. What I want to do is spend the next few minutes covering 2 specific practical examples of areas within Android which I think as beginners you'll be able to get a lot out of. This is going to get a little bit more technical. There's going to be a little bit more code. So if you're not comfortable with code, you can spend the next 10, 15 minutes wondering why you've come to a developers conference. The first thing I want to cover is services and alarms. So they go together, or at least they should do, if you're using them the right way. So services are incredibly powerful. They're what lets you have these background data, these applications running in the background. And because of that, they have the potential to they give you the potential to commit 4 of the 5 sins we talked about. So sloth, gluttony, hostility, and arrogance are all things which you need to be cautious of and aware of when you're creating your services. So what we're going to do now is have a look at how you can avoid being that guy. And that guy is the one who creates the app that's kind of cool, does something useful, but you always end up uninstalling it because it drains all of your battery and you can't find a way to turn it off properly, and it doesn't give you any of the options that you need to stop draining all of your resources. So that's what we want to try and avoid. And so these are some of the ways in which you can go about doing that. So I think most of us probably know, hopefully, the way the application lifecycle works, that your background services may be killed by the runtime in order to reclaim resources. How many of you know what happens next? Not too many. Okay, so what it does is the runtime is then going to restart your service as soon as it possibly can. So it will kill it to gain some resources for the foreground activity, but it'll try and restart it as quickly as it can, often within a second or within a few seconds, if it possibly can. So that's what happens by default. The thing is, as a developer, you know whether or not that's actually legitimate. You know whether or not your service needs to run. So wherever possible, you should tell the system that's actually not required. And you can do that as of Android 2 using onStart command. This is an extension of onStart, or a replacement for the onStart command, which was in services prior to 2. And what the difference between it is that it lets you return a code which tells the runtime exactly how to react to the service being killed. And the return value I want to point you to today is start not sticky. So by returning this, you're telling the runtime, if this service gets killed, don't restart it. Just let it go. This is perfect for services which are going to be happening on a regular basis. So if you're polling for updates every 10 or 15 minutes, if it misses this particular update, it's probably not that important. This is a way for you to be able to work with the system to keep the system more responsive and to keep your app and other apps more responsive. So that's definitely something you want to consider for any service which performs a single action which gets repeated on a regular basis. Related to that, so we talked about background services, and there's something similar called a foreground service. And what a foreground service is a service which runs still invisibly to the user, but which is interacting with them directly. So 2 good examples of that are a music player and turn-by-turn navigation. So if you have an application like that, it needs to run in the foreground. The thing about foreground services is that the system treats them the same as it does foreground activities, which makes it much, much less likely for them to get killed, which means that if you have a number of foreground services, it can have a big impact on the overall system performance. So the key is to not use foreground services unless you absolutely have to. If you do have them running, you should always give users the opportunity to first see that it's running, and secondly, to find ways in which to turn it off. So from Android 2 onwards, foreground services need to have an ongoing notification. So I would urge you all, if you are developing for systems prior to 2.0, to use the ongoing notification anyway. It's a way for users to be able to say, at the moment it's more important for me to have system resources than to have this application running. It's a really important way of being able to not be hostile and to be able to help the system to manage its resources effectively. So we've talked about the way that the runtime can kill background services or how you can help the user to kill foreground services. The more important thing is for you to kill your own services. Services consume resources, they're in the background, they should be running for the smallest amount of time possible. So to stop them running, you call stop self. So within your activities, within your services, whenever they complete a task, and ideally your services should only be running in order to fulfill particular tasks or if they're bound to an activity. So as soon as the activity goes away, they should be unbound. If they're in the background, they should be completing one task, one action, and then call stop self. So a way to be able to implement this is, again, using the async task, which we talked about in combination with start not sticky. So what we can see here is we're kicking off an asynchronous task. When that completes, we're calling stop self. So this is going to ensure that the service is running for the smallest amount of time possible. So the only thing better than making sure that your services are well managed is not starting them to begin with. In fact, you need to ask yourself, do you actually need a service for the action which you're trying to perform? So the question is, well, what's the alternative? And the alternative is alarms and intent receivers. So intent receivers are a great way to be able to make your application much more event-driven. And what we're going to do now is have a look at a way that you can use alarms and intent receivers to replace a service which would be running in the background simply to do regular polling. And that's definitely not something that you want to have. So the way you can do this, so the way alarms work is that they let you set an event to happen either in the future or on an ongoing basis in the future. And an intent receiver is a way that you can say that you want to listen for something, an intent, a broadcast intent, either from your own application, a third party's, or indeed the system, and then react accordingly. So what we're going to look at now is how to replace this polling with alarms and intent receivers. So you start off within your application, you create a new broadcast receiver implementation, and within an on receive is where you're going to perform whatever action you want to have happen on a regular basis. So in this instance, we're going to start a service. It's going to be the sort of service which is going to run up, simply do your update and then kill itself. Once you've created it, you obviously need to include it in your manifest using the XML text above. And you include an intent filter now, which is going to specify a broadcast intent to listen to. So now whenever the system broadcasts or refresh this intent, your application, my receiver, is going to get spun up, and on receive is going to get called, and this update is going to happen. So how do you get that to happen? Well, you get that to happen using alarms. So what we've done here is we've created a new alarm using the alarm manager, which creates a new intent, which is refresh this, which is going to wake up the device every 15 minutes and execute this receive handler, which we saw beforehand. Now this is really neat because this all happens even if your application is totally not running. So if it's been killed, once you set these alarms, they will continue to happen without your application having to run in the background, consuming resources. There is a risk with this particular implementation though. I'm sure you can probably spot what it is. If you've got 10 applications, each of which set one of these repeating alarms to happen every 15 minutes, and it takes about a minute for it to complete this update, you're going to end up with your phone on constantly while it's performing the updates for all of these different applications. So there is a solution for this, and that's using inexact alarms. Inexact alarms work almost exactly the same way, but instead of calling set repeating, you call set inexact repeating. And what this does is it lets the system phase shift these alarms, which are all going to happen at close to the same time, to happen at the same time. So rather than 15 alarms happening over the course of 15 minutes, you have them all happen at the same time or very close to each other in a way that the system is able to optimize. So this is going to have a dramatic impact on your resource usage. So if you have something which needs to happen regularly but doesn't have to happen exactly, use inexact repeating rather than repeating. So very quickly, before I run out of time entirely, I want to have a quick look at location-based services. And so this is something that's really fundamental to the way mobile apps work. location context is really important. It's also really important to get wrong. So this is a really simple implementation of a location listener. So those of you who have played around with this beforehand can probably spot the problems a mile off. So what we are doing wrong is we've got, when we request our location updates, we're not having any limits on the frequency of those updates. So this is saying no matter how much time has passed since the last one, even if it was half a second ago, even if the user hasn't moved, every time the GPS gets a new signal, I want to fire my code. And what's more, we're specifying the GPS explicitly. Even worse, we're doing that using a string literal. So how do we improve that? So these are some of the things that we need to be looking at. How often do we need to get these updates? Do we need to use a specific provider? And what happens if that provider isn't available? How accurate do we need to be? What's the impact of all of these things going to be on our battery life? And what happens in the case of GPS when it's going to be jumpy at the beginning? So how do we create that instant positive user experience where they don't have to wait for a GPS to settle? So the first thing we want to do is restrict those updates. It's one of the fundamental things we talked about earlier on, is limiting the number of updates. So right here, quite simply, we've specified a minimum frequency, or a maximum frequency, I should say, which is saying, well, we don't need updates any more often than every 5 minutes. And we don't really need to know if they've gone anything less than a kilometre. So we can put that in really easily. And that's already going to make a dramatic difference to letting the system manage that GPS resource. Next, we want to remove that GPS. So we definitely don't want a string literal. We really don't even want to specify a particular provider. We don't know what's going to come out in the future. We don't know what the user has enabled and what their preferences are. So by using the criteria class, we can specify the power consumption that we're after, the accuracy that we require, and a number of other hardware requirements that we do or don't need. So by doing this, we're able to ask the location manager to get us the best provider based on what's currently active and available on the system. And that's going to make sure that we can do a lot of things. That's going to make sure that we always have the best provider for the current situation. It's going to make sure that we only have active providers, so we're not left with not being able to get location at all just because the user isn't using GPS, and that's what we would prefer. So now we've got a much more efficient solution, and we need to think about what the implications are for your actual app. So one of those things is what I mentioned a little bit earlier on is GPS. So when you start up a GPS, it will bounce around. And so you'll have to wait, sometimes minutes, until it's a nice, solid, accurate value. So one solution to this is to implement a back-off pattern where you're using multiple location listeners so that you can get a result and as accurate as a result as possible before you're going to back off and let the system use the much more managed, unfrequent update approach that we talked about. So how does that look? So it works much the same way. So the first thing we're going to do is create a location listener for our best provider, the one which uses the criteria we specified and has the maximum frequency and distance requirements. We're also going to implement 2 location listeners, one for a coarse provider and one for a bounce provider, which is going to take care of the GPS sort of stuff. And both of those are going to have no restrictions. And this is what it's going to look like in code. So we're going to have a look at the on-location change for the coarse listener at the bottom. Is going to say, well, I'm going to assume that the coarse listener, which is generally going to be the Wi-Fi cell ID approach, is going to be able to give us something quickly, albeit not particularly accurately. So I want to grab that and use it so the user at least has something, but only once. Then we're going to use the bounce provider to say, well, look, I want every update from the GPS until it gets better than within sort of 10 meters of accuracy. At that point, I'm willing to fall back to our more managed approach. And so this should be able to give us a location as quickly as possible and then rapidly sort of scale down once we increase the accuracy of our GPS receiver. So, finally, to summarize, hopefully by the end of today or the end of this session, and certainly there's a lot of other Android sessions over the next 2 days that will hopefully help you to do this, we want you to be good developers, not lazy developers. Think about performance and how it's going to impact your application. Think about the user experience, respect your users, respect the system, and think big. Think about how you can create something beyond what's already been done. So, thank you very much.